I'm going to say welcome to everyone. This is Hoosier Interfaith Power and Light's Conservation for Congregations webinar. I'm Ray Wilson, and I'll be your moderator for this evening. I'll be assisted by Angie Williford, who you may have heard her voice. She's our office administrative manager, I should say. We have 5 great speakers for you this evening, and I'm not. I wrote this down. I wasn't sure where. Well, I can tell you that as far as I know, one of them's in Texas, and I think one may be in Michigan, and the other 3 may be in Indiana. But these days, you never can be quite sure just where people are. But I think we'll get through this. I can suggest to you that we would like to mute all the guests, and we'll keep you muted until the end of the speakers are finished, and then we will unmute you. If you have questions as we go along, so that you don't forget them, feel free to click on the chat and type them in there, and that way we won't forget them, and we'll give everybody a chance to get answers to those questions. I'd suggest that you go to speaker view on your Zoom, if you're up in the right hand under view. If you want, you might find it better to be in speaker view rather than gallery. And I think that's about it as far as that's concerned. We will be following up tomorrow with an email, just giving you some information about the speakers and contact information in case you want to get in touch with any of them. And we'll be sending you a bit of information about HIPPL to learn a little bit more about us. I'd like to set the stage for this webinar by telling you that HIPPL has a goal of getting 100 congregations in Indiana to sign up for their Thriving Faith Communities project. Unfortunately, we had the same goal this past year, and then COVID happened, so we didn't get it done. But we have a very important program that we think that most of you will be interested in. Just to whet your appetite, I've been following a number of congregations. We have about 20 congregations that we follow and get data from all year long, and I have 12 of them that I particularly know that we have all the data for. And just to compare 2019 to 2020, and you can see that's a special year, but just to let you know, those 12 reduced their energy consumption by 18.5% in this past year. They, more importantly, maybe reduced their energy or their carbon dioxide emissions by 27.5%. And that translates into 881 tons of carbon dioxide that didn't go into the air. They reduced their utility costs by 24.7%, and that translates into $125,000. That's real money. So to learn a little bit more about how they did it and how we can do more, we have these great speakers, and I can vouch for that. They are really something special. So I'm going to introduce the first one. He's Colby May. He's the founder, president of LIT Consulting, and he has the byline here of Energy with a Purpose. Colby is a certified energy manager, having specialized in energy efficiency for the past 20 years. He has performed energy audits in over 5,000 commercial-sized facilities across the nation, including schools, churches, seminaries, local government, and universities, K through 12, and schools, and more. Colby has a master's degree from Gordon Conwell Theological Seminary, where he majored in ethics and society, and a BA degree from Texas Tech University. And interestingly, he spent time in the Democratic Republic of Congo during the Kivu conflict, and he focused his studies there on local churches' response in time of conflict. And I can tell you that he had a special situation in Texas. As you know, they had a bad winter proposition to deal with, and his congregation became a resiliency center for some of the people in his neighborhood. So with that, Kobe, I'll turn it over to you.
All right, thank you very much. Yeah, we call it Snowvid here in Texas. We had some of that Indiana weather coming up. So I'm gonna make sure. Can y'all see that? Thumbs up if you can see that. Good. So as he said, I wear a number of unique hats, right? I'm a certified energy manager. And if you don't know what that is, basically I'm certified to manage energy. And I am an ordained mission pastor here in the Texas area. And right after seminary, I actually went into seminary really wanting to study injustice. Why do we do what we do as a culture? I left passionate about the local church, because if we want to change the hands, although the church is imperfect, if we want to change the hands, we have to change the heart. So our whole focus as a firm is using energy efficiency, energy audits, both to impact creation care, but also to impact missions and ministry. It's a very unique niche that we're in, but we love it. And we use energy audits actually to impact change. And we're going to talk about energy audits today here in 10, 15 minutes or less. To be honest, any one of these topics we could spend a week on, because it's so in depth and there's so much potential when it comes to energy efficiency and energy management. So I want to share a few quick facts from houses of worship, right? According to State of the Plate, in 2013, we tithed about $50 billion per year to our respective congregations. And if you could guess what our second largest budget item is, typically behind salaries, it's utilities. We spend, of the 50 billion, we spend about 10 billion or 20% per year on utilities and facilities. I think that's a big number, and I want to push into that number here a little bit more. We spend about 2% on missions and so on and so forth, but I want to focus on that 20% on what we can do from an environmental impact, but also in ministry and mission impact. According to the EPA, the Environmental Protection Agency, 30% of the energy we use within our churches, within our homes, is wasted. And if we were interactive, I'd ask more questions here, but for the sake of time, when you think of it, what does that mean? Basically, it means I can recapture up to 30% of my energy by changing the way I operate. I don't have to spend a dime in order to save up to 30% of my energy. I don't have time to talk about all of that, but I'm going to give you a few examples as we go through. And Ray, if I go a little bit over time, please let me know, okay? I want to honor my time slot. America's houses of worship, there are over 400,000 congregations cut energy use by 20%, right? We could save nearly $1 billion for ministry, missions, education, and more. We could cut electricity use by 4 billion kilowatt hours. We could prevent more than 3 million tons of greenhouse gas emissions, equivalent to about, this thing is covering it up, about 550,000 cars, and equivalent to planting about 700,000 trees. And I'm a big believer in solar, renewable energy, but first I'm a big believer in changing and managing the energy within my building. If I can reduce that by 15, 20%, and then install a solar or whatever renewable source, that's less upfront money, that's less materials, etc. on my church. I want to talk about that more as we have the time, but really quick, when I'm talking about energy audits within houses of worship, within seminaries, there are a lot of things that get in the way and prevent us from really doing the effective job we need to do. First, churches, especially with COVID, we're under-resourced. We don't have the resources we need to invest into new HVAC, new lighting, new controls, which is okay, right? But that's some of the things that get in the way. Facility management, energy management is undervalued. I'll talk about that here in a second. A lot of many times the pastors also wear the hat of facility manager. If you're a bigger congregation, you might have a staff of 5 or 10 people that do facility management. We've done audits at churches that are 1,000 square feet or 1 million square feet and everywhere in between. So we've seen everything. Leadership does not understand potential of energy management, too many responsibilities, especially with the facility manager or custodial staff or whoever's wearing that hat. You have too many hats, you have too many responsibilities. As a result of everything I'm talking about, what we see in energy management is that individual is in reactive mode, putting out fires, opposed to proactive mode. So these are just some of the things that we see that get in the way. So why energy audits? It's our second largest budget item. The cost of energy is increasing. It's high. It's a little different here in Texas than it is in Indiana, but we do most of our work now in Indiana. I'll talk about that in a second. 30% of the energy we use is wasted, right? Facility managers have too many responsibilities, right? We're called to steward his creation. It says clearly in scripture, and energy audits help us, right? Uncover energy use and develop a plan. So if I'm going to build a house, right, I need to have some type of blueprint, right? If I'm going to effectively save energy, and we can save energy without an energy audit, but if we want to effectively save energy, right, it's good to have an energy audit or an energy plan that maps this out. I'm going to build my case, right? An energy audit, by definition, is an inspection or survey and analysis of the energy flows for conservation and energy management within a building. Just a simple, real quick definition. Again, there's a lot of material here. I wish I had time to push in, but for the sake of time, I do not. But I do want to say here, right, energy audit, in my very strong opinion, right, should be the first step or one of the first steps involved in energy cost control of my facility, right? There's a lot that go into an energy audit. I'm not going to go over all those, but I do want to make the point that it should be one of the first things that we do. I also want to say there are different levels of energy audits. I can get sometimes utility companies will come and do just for a bird's eye view. We call that a preliminary energy audit. It's good. The best is more of an investment grade energy audit, right? Now, looking at these two graphs, many times I say I do energy audits. And the first thing people say was, great, I just changed my lights to LED. And that's good. That really, really is, because it goes a long way. But look at these stats, right? This is in Texas, Oklahoma, Louisiana, further than south. And the stats are maybe slightly different in Indiana, but the largest user of energy in my home, in my office, and in my church is going to be HVAC. In the South, especially in Houston, 70% of my utility bill is on HVAC. So what's one of the things that we should focus on, at least the most? I'm not saying ignore everything else, but we should focus on how we control our heating, ventilation, and air conditioning. That is so, if you get anything from this, right, focus on how do you control your HVAC. And if Ray, if you want me to come back in 2 months or whatever and just talk about controls, happy to do that. I don't have the time, but an energy audit should focus mostly on HVAC, but also the rest. But I just wanted to show the graph here for your sake. We talk about energy audit basic types. There's level 1, level 2, level 3, obviously more in depth the more you go. But from a bird's eye view, I want to focus on these 5 areas. I have 1 slide per area. Again, each slide could be a week-long class. But an energy audit, I'm looking at, the first thing I want to look at are my utility bills. It's like a gas gauge into a car. When you know what you have in the tank, you make better informed decisions. Now, I know Hoosier Interfaith Power Light has an excellent program called Energy Stewards. If you want to know more about that information, I encourage you to reach out to Ray and team about that. But it's an excellent program that you can use to actually benchmark your facilities. But 2 questions that we want to do, the foundation of energy audit is the utility bills. How am I doing? How do I know, right? That's one of the first things. There's different units of measurement. Again, I don't have time. Typically, your electric, when you're benchmarking your utilities into a monthly basis, right, and you're going to compare that to previous months just to show how energy efficient you have been. You're doing that with electric, kilowatt hour, demand. I don't have time to talk about demand, but that's a big thing. And then gas, right? But benchmarking tells us a story as an energy audit. For example, this graph here is a church over a specific month. I see a peak here, and it's like, okay, why is the church peaking at 3 o'clock in the morning or 9 o'clock in the morning? That doesn't make sense. Something like this will tell us a story. Let me give you one more example of the importance of benchmarking. Again, I know I'm going through this quick, and I'm sorry, but this is a school, right? I'm going to give you a couple quick seconds to answer and put it in the chat. What do you see wrong with this graph right here? These are months, right? Energy use for a particular month for a school. And I can't see the chat, but if you said June, July, and August, then you were correct. Why is this specific school using so much energy in June, July, and August? If I did not benchmark, I would not know. They're completely unoccupied. So my hope is the energy use would be this much lower. We were able to find a no-cost solution. It's a pretty complex solution, but it's a simple no-cost solution, and that no-cost practice saved that school $40,000 simply by changing the runtime hours, the outside air dampers, and so much. So again, benchmarking, it tells us a story, right? And then we're able to use what we find and investigate in a more equipped way. Here's a screenshot of the Energy Steward program. I'm sure you guys might talk about this a little bit more, but I do encourage you to look into it and to reach out to Ray and team if you want more information on that. Another thing we're doing when we're looking at a church was we want to look at that 65%, the HVAC. How do you control it? For example, if I have the ability to zone my church, I'm only in this area, why am I conditioning my entire church if I'm only in this zone? We can put these in unoccupied mode while keeping this one on, or something else we might find, right? This zone is controlled by a 10-ton unit. Maybe this zone is controlled by a 4-ton unit. If I'm going to schedule a meeting in my church, why not think outside the box, right? Think, as managers, right? Think outside the box. I'm going to schedule the meeting in this zone, which is controlled by a 4-ton unit and not by this 10-ton unit. There's so many more examples, and I actually wish I could stay here and share all these examples with you, because there are literally hundreds of examples just in the way you operate your heating, ventilation, and air conditioning that can make an impact. But for the sake of time, I'm going to continue to move forward. HVAC, heating, ventilation, and air conditioning. When I'm looking at HVAC, we're looking at the types of systems that you have. Do you have a central plant? Do you have split systems? Do you have heat pumps? We're looking at the size of the units, 300 tons versus 3 tons. The age, we typically, industry standards, if you have equipment older than 20 years, we automatically recommend replacement, right? Our energy audits are neutral, third party. We're not selling a thing. So there's nothing to gain for us. But when we see older equipment, older than 20 years, we typically recommend replacement. Gas is 3 to 5 times cheaper than electricity. When you're looking at it from an energy efficient point of view, gas is much more efficient than electricity from a BTUs. If I break electricity down to British thermal units, same thing for gas. Gas is 3 to 5 times cheaper, right? Now this unit right here has crushed in coils. I'm talking about the system condition. If you look at the coils of your HVAC, if up to 10% of the coil is crushed in, you can lose up to 30% of the efficiency of the unit. All right. We also look at lighting. I'm not going to spend a whole lot of time here, but here's T12s. This T5 is actually more equivalent to an LED. But if I have, 100 fixtures that are 4 bulbs each at 34 watts, I'm spending $5,100 a year. If I switch to an LED 2 lamp at 100 fixtures, I'm spending more around $1,350 per year. So you see a big impact on your lighting by switching from a T12 or a T8 to more of an LED. There's other things. Again, I don't have time to go into everything. This is an audit we did at Harvard. Their building envelope makes a big impact. This is a single pane window versus a double pane window, and there was an 8-degree delta between the two. The stronger your building envelope, the less you're going to use from an energy management point of view. There's other parts, plug load, the things you plug into the wall. Up to 70% of plug load is what we call phantom load. The largest impact is behavior. The largest opportunity everywhere is behavior. It impacts HVAC, lighting, envelope, water, domestic hot water, so on and so forth. So these are, again, it's like drinking out of a fire hose. I'm guessing right now because I'm going kind of fast, but there's just so much to an energy audit. I just have 2 more slides, and then I'll hand it back off, Ray. This is an example we did in Houston, St. Cecilia's Catholic Church. If you can see this graph here, their demand does not vary, remains constant, which was a concern to us when we looked at their controls. They had everything going on 24/7. The boilers and the chillers were both operating 24 hours a day. We told them to change a number of practices. They were able to save 20%, or excuse me, $20,000 just in changing the schedules and the way they operate their HVAC, and so much more. So that is a lot of information, and I'm sorry, but one thing, we do most of our work in Indiana because of the Center for Congregations Resource Grant. We've done about 20 churches under that grant. It's actually a matching grant. So we've done Traders Point, Mount Pleasant, a couple seminaries, and many, many more. So if you are interested in a resource grant, we also have a limited number of resources that that we can actually match their match, which would be 0 out of pocket for your house of worship. So no strings attached. We're not selling anything. We're not saying you have to do anything, but if you are interested, let us know, shoot me an email, and that is it.
Thank you very much, Colby. You're right. This is fast and furious, and then you're exactly right. We could spend an hour, 2 hours, or a half day or a day just talking about this. So thank you very much. Appreciate it. I'm going to go on to our next speaker, who is Monroe Fritz. Monroe's a certified infrared thermographer and has been an Energy Star building professional and building envelope specialist for 20 years. His professional credentials include certification training with such diverse groups as the American Air Barrier Association, if you knew there was something like that, ResNet, which is Residential Energy Services Network, the Infraspection Institute, the Building Analyst Professional Program from the Building Performance Institute. Who would have known? Anyway, Monroe has conducted energy audits, lower door tests, building diagnostics in more than 7,000 homes, churches, and institutions and commercial facilities. I can't even count that high. He has projects, his projects included everything from Habitat for Humanity homes to training facilities for the Army's Special Operations Forces. Now, I can't imagine why that would be special. He's the author of Chasing Sacred Air, Handbook for Energy Efficiency in Churches. I happen to have a copy of it, and I have personal experience with Monroe. He came to my congregation and pointed out the gaping holes in my buildings. So take it away, Monroe.
Thank you, Ray. We'll see if we can get a screen share going here. I want to do something opposite to what Colby has done. I'm so glad we have a recording of that so that I can go back and do my homework on the things that you ran through there, Colby. But I'd like to go to a very specialized and a simple concept of something that's one of my favorite issues when it comes to energy efficiency in buildings. So I'm going to start with this comment about chasing air. It's a concept, as I said, and it's a sort of techno slang, this chasing air phrase. It comes from TSI Energy Solutions, the energy efficiency folks that I've worked with for the past 20 years, but it just refers to a way of evaluating, diagnosing, and understanding the air exchange that goes on in our buildings, basically just how leaky they are. It's all about quantifying the rates of air infiltration and exfiltration and seeking the control of that very important aspect of the building performance. So conceptually, I really only have one simple goal in mind, and that is to impress upon you how important air barrier performance is in a building and why it deserves some special status in our efforts to improve overall building performance. So let's start with kind of an absurd example. So take a look at this building. I hope you're not involved with any kind of building that looks quite like this, but it's an absurd example. If I came to you and I said, well, we need to make better use of this building, so let's put a big HVAC system in here so that we can get some comfort and some people can use this building. Now, you would know intuitively that this isn't going to work because you can see clear through this building. There's unlimited air exchange in this building. So you would know intuitively that HVAC isn't going to work in this building. So let's take another aspect of this. What if I came to you and I said, well, why don't we put a big insulation package in this building so that we can get it built up to where somebody can use it? You also would know intuitively, hey, insulation isn't going to help this building. We have unlimited air exchange going in and out of this building. So these are absurd examples. But my problem, based on my experience, is I've walked into many buildings that looked perfectly normal. And after going through them and doing audit type processes like Colby was describing, I'm shaking my head and I'm saying those buildings are actually performing very much like this building right here, even though they look entirely normal. So I want to start with this statement right from building science. A compromised building air barrier will jeopardize the integrity and effectiveness of all other building efficiency processes. Jeopardize all other building efficiency processes. So what this is saying is this particular problem, only one of many challenges we have in our building performance, the air barrier performance, is very special because of the way it impacts all of the other things that we try to do. This is a common way of saying it. This is the way I say it when I'm out in the field working with people. Hey, folks, you can't control anything in a leaky building. Now notice, I didn't stammer, I didn't stutter, I didn't hesitate. I absolutely believe this based on my experience. We have to control this air exchange in our buildings before we can make any progress. Take a look at this statement right here, if you would. We do a lot of compensating in our buildings for building performance. We do it with HVAC systems, and we do it with insulation processes in particular. We do a lot of compensating for air barrier problems instead of remediating or fixing the problem. And one of the reasons we do that is because our HVAC are so service oriented and they are so professional that they can do this. They can do that compensating process, but we shouldn't be asking them to do that for us. It's the wrong orientation. It's the wrong priority. We need the air barrier problems to be solved first, and then let the HVAC folks do their part of it, which is what they do best, rather than compensating for problems that in a technical sense aren't really there. So what I'm suggesting here, when you look at your own building and you consider your own congregation and the building performance, is not that the air barrier is necessarily the #1 problem, but we should consider it early on in our audit processing and in our evaluation process because of the peculiar way that broken air barriers have of affecting all of the other work that we're doing in our building. So let's just ask some practical questions. What does an air barrier leak look like? If you've got an air barrier problem in a building, what could it look like? If you've got excess infiltration and exfiltration going on, here's some examples. This is a classic ice dam. Now, if you know anything about the definition of an ice dam, it requires 2 different temperature variations on a roof. So up high on the roof, we get warming and we get melting. It comes down and hits the cold surface at the edge of the roof and freezes. We've got thawing and refreezing going on. Ice dam is the result. We see these spectacular icicles and the damming of ice on the edge of the wall there. there's a very good chance when you see this picture could be the result of an air leak, a misbehaving air barrier in this building. Doesn't have to be, but this could be very much a picture of an air leak in a building. What else can a building air look like? Try saying that a few times fast. This is the classic, a stained ceiling tile and a suspended ceiling in a building. I think every commercial and institutional building in the United States has a suspended ceiling in it somewhere. Usually if a building manager or facilities manager sees that stain in the ceiling, first thing he does is he calls his roofer and says, hey, we got a leak in the roof. Come and get it fixed before it rains again. But as an air barrier specialist, we understand a lot of times that is not the case. This could very well be a picture of an air leak in a building. So we have an intrusion and infiltration of hot, very humid summer air getting in the space above the suspended ceiling. It runs into a cold surface, such as an unprotected air conditioning duct, or maybe a chiller line, which is unprotected. We have condensation, it drips down on the ceiling. This is potentially a picture of a leak in an air barrier in a building. Mold, our old friend that gives us all the heebie-jeebies. This is, once again, the possibility of being an air leak issue. Not saying that it always is, but it's one of the things that has to be considered. We know that mold requires 70% plus humidity, and that's one of the things an air barrier leak can do for you in a building. So when we see this picture, is this possibly the result of an air leak issue and other ventilation issues? It definitely could be. Condensation on the windows. We're called out to solve these problems a lot of times, especially in high-end fancy homes, it seems like, that have a lot of complicated air barrier issues going on in them, and some very fancy ducting systems going on. It's a ventilation issue also much of the time, but whatever it's causing, a lot of times there are air leaks involved, so that we get our humidity lines and our temperature lines that cross, and we get dew point type phenomena like this, condensation. This indeed can be a picture of an air leak in a building. Now this picture here just represents a simple comfort issue. Here we have a person who's got a space heater, very common thing in a lot of buildings, underneath their desk at work. Now we don't know why. Maybe this person just has, maybe it's a personal problem, maybe they just have a low metabolism. Or you may get into a room with multiple desks and workstations. People all around are using these same kind of things. Maybe they would tell you, if you asked them, that the whole room feels drafty or that their feet are cold. Comfort issues and anything that has to do with a comfort issue can often be traced back to an air barrier issue. We are very likely, when we have comfort issues, to call the first people who are handiest to us and that we know and appreciate as professionals in our communities, which is our HVAC people and our insulation people, and we're going to ask them to address this. But as I said earlier on, this may not be an issue that they should actually be doing their work on. This could be an air barrier issue caused by an air leak in a building. So let's ask the question, what does an air leak in a building look like with infrared? Here's the people to ask, U.S. Army Corps of Engineers. For years now, U.S. Army Corps of Engineers builds constantly all across the United States, coast to coast, and in many places around the world. Constant new construction going on. Every new building, with very few exceptions for the U.S. Army Corps of Engineers, is required to have a whole building air leakage test performed on it. They want to know when that building is commissioned and they cut the ribbon that that building has airtight standards that are met. And they want that in every building. But curiously, we're talking about what does an air leak look like. When you go perform these kind of tests, which we've done over 200 of them at TSI for the U.S. Army Corps of Engineers, we find that we're always required to go into that building under ASTM specification 779, which simply says you're going to go in there with thermographic capabilities. You do have to go in there with infrared capabilities, because if there happens to be an air leak, they know that infrared is one of the easiest tools to use to help find air leaks. So we've actually got this process of looking for air leaks with infrared endorsed indirectly by the Army Corps of Engineers. So here's what air leakage can look like to infrared. Now we have a very strange building here, and you will see the proverbial suspended ceiling and the digital image on the right. And this is very odd that they would have in a semi-outdoor space have a suspended ceiling like that. But some architect who wasn't quite on his game when he designed this building put that in that situation and then went on top of that suspended ceiling and piled insulation on it. So he was expecting that suspended ceiling to act as an air barrier. And there has never been a suspended ceiling on God's green earth that has ever been able to perform as an air barrier. So it's a mistaken design right from the start. Our infrared on the left clearly shows the heat coming out of the building. And if we go up into the office, up above that, where the original complaint had been, comfort issues and high utility bills, we see the cold spots in the framework as it's come up from that parking spaces down below. So this is what the infrared sees when you ask it to go looking for leaks in a building air barrier. This is an example, once again, matching images on the right and on the left. A very pretty, a really beautiful fellowship hall added to a 100-year-old church in southern Indiana. Notice the bulkhead on the right as it goes around the top of the room there. And you will see that that bulkhead, according to the infrared, is full of cold air. So if you trace the digital image over to the window on the left there, when we got up in there and looked around, we found that when they had put the old building and the new building together, there was a break in the air barrier and it was allowing almost unlimited exterior air infiltration into this bulkhead. So on this particular day, it was only about 35, 40 degrees outside. All that was really happening was we had an additional load on the furnace because of the cold surface of this bulkhead and the walls directly below it. But you have to ask yourself, what would happen if we had a 10-degree below storm, which is rare in southern Indiana, but it does happen, and a high wind? How much cold air could we put into that bulkhead? And you'll see a sprinkler head up there in the top above this room as well. And we wonder what the exposure element might be there and what the potential danger for catastrophe would be, all because of an air leak. Moving along to this particular one, this is a classic example. Air barriers leak where big major air components come together, such as walls and floors. And when you see this blaze marks on this floor, literally coming across this carpet, remind yourself that infrared does not see moving air. But when air moves in and infiltrates that aggressively, it actually creates that blaze mark as it cools the top surface of that carpet. And then the infrared sees the evidence of that invading, literally flowing air as it comes across into the room. So this is an infrared picture of an air leak in a building. So one last example. This is a 4-story high office building in the wintertime. And you will notice that the wall that we're seeing with most of the blue tones, you'll see that there is some yellow and gold that represents heat coming out of the building. There are some conductive pathways, but overall, the wall of that building is performing pretty well until you get up at the top. And here again, we have an instance where air barriers were not put together during the construction process. So inside this building, we have the stack effect. We have rising warm air. It's coming up and it's literally pushing it against the top of this building. It's intersecting this break in the air barriers where the roof and the walls come together. And it's coming out so aggressively that it's cooling in these blaze type signatures that the infrared catches up on, right down the exterior face of the building. This is an extraordinary amount of air exfiltration of a building caused by the stack effect, but it is an infrared picture of a leak in an air barrier. So that's just a few of the many ways that air can leak out of a building. And the problem with investigating these kinds of things is a lot of times you need some additional help to recognize these kind of situations and see them for what they are. So I just want to go back and sum up here real quick. Since we can't control anything in a leaky building, remember, that's my mantra, we can't control anything in a leaky building. There's an urgent need to prioritize and remember the big picture. Not that we're going to go into your building and say, hey, the air barrier is absolutely the top priority, you should do that. No, that's not the case. As Colby just told us, we're spending most of our money in another area. but we prioritize it in the sense that we would like to have these air barriers and these air leakage issues addressed before we get too far along in our other categories of remediation, because of the peculiar nature of the way air barrier issues can sabotage our other efforts in energy conservation. That's a wrap, Ray.
Thank you very much, Monroe. Yes, again, I can vouch for what a leaky building looks like. We certainly have some, or had some, we've done a lot at our church. Let me get on to our next speakers. The first one is Kim Shippers. She's business development with Dilling Group. Kim has over 30 years of experience identifying and working with industrial clients across the country, starting with her career in economic development, recruiting industrial clients to her community. But for the past 11 years, she's been responsible for sales, promotion, and account management at Dilling Group and subsidiaries for construction and maintenance services across the United States. And she's going to be tag team here with Don Glowinski, account executive with Comfort Systems USA, Indiana. Don is responsible for sales of HVAC and plumbing repair service, preventive maintenance programs, design, build, and plan spec projects. His past experience includes owning a separate mechanical contracting company specializing in HVAC, refrigeration, and plumbing services for residential, commercial, and industrial clients. With that, I'll turn it over to Kim.
Thank you. Well, we'll both get started, but Angie, if you could pull our slides up, that would be wonderful. This has been a very interesting conversation, and we've really enjoyed hearing the expertise in the room. So thank you for including us in this. You can go ahead and go to the next slide. We wanted to introduce our companies to you as a resource for the work that you have. So Dilling Group is 73 years been in existence in Indiana. We started in Logansport, Indiana. In 2018, we joined with Comfort Systems USA. We have merged with the Comfort Systems Indiana office in Indianapolis last year. So we have a third generation family leadership. We are licensed in 25 states and work all across the country with over 500 employees. We do small work, we do big work, but this is just to kind of give you a little bit of a background of our experience. Our parent company is Comfort Systems USA with over 140 locations across the United States. You can go to the next slide. So the services that we provide are mechanical, electrical, HVAC, maintenance, and engineering. So we'd like to think that all of these services or tools in our toolbox would be of value to you. In the mechanical, we can do plumbing, sewer work, process utility piping, boilers, chillers. Electrical work, we do everything from lighting to medium voltage systems. HVAC services is building controls and rooftop units, a wide variety of services there. In maintenance, we are doing constant maintenance programs and coverage agreements to help maintain your excellent facility. Next slide. So we always talk about safety. That's always a part of every presentation that we make. We always talk about safety because our core values are these 5 core values: being safe, honest, respectful, innovative, and collaborative. And so I have my safety moment for the day is about distracted driving. And it is something that's very alarming for everyone. Texting is the most alarming distraction that we have. You can't drive safely unless the task of driving is your focus. It's estimated that every 2 minutes, the typical driver makes 400 observations, 40 decisions, and 1 mistake while driving. That's why it's always important to never assume that the other drivers will make the right decision. So that's my safety moment. You can jump to the next slide. I'm going to turn it over to Don now, and he is going to lead you through this next portion. Unmute though first.
There we go. Can you hear me now?
Yes.
Great. Thank you. The reason we double teamed is so that you'd have Beauty and the Beast. Otherwise, no one would come in if it was just me. But this is really neat. I really didn't know what to expect. And So a lot of what we're going to go through here is what you guys have already heard, but we're the guys that can get it done. After all the issues are discovered and plans are made, we will come in and execute that project for you. Building envelope approach, the air barriers, roof walls, windows, penetrations, how to find the biggest energy losses in your buildings. I call it looking for the low-hanging fruit, which they've already talked about, the air barriers, the lighting, things like that. That's the easiest, quickest way to get to that. And then ultimately, I think the goal of this group is to be more of a carbon neutral. And how do we get there? It's building envelope and energy efficient equipment so that we're using less of the energy. We can't decide where we always get our energy from, but we can decide how we're going to use it the best way. We can go to the next slide. And I apologize, I'm losing my voice. There we go. Studying the building envelope. What is that? We've heard a lot about it. Well, that is your building. It's the roofs, walls, the connections, like we saw on some of the slides, the building penetrations, where the pipes and conduits, your chimneys, all that goes through, doors, windows, and all that. A lot of this is the low-hanging fruit that we've talked about, and just taking care of this and getting these things found and corrected can save you, according to the Department of Energy, up to 15% on your energy bills. Depending on where you're from, there may be grant money or rebate money to help you accomplish some of this. You go to the next slide. This is where we come in. This is our expertise on the heating, ventilation, and air conditioning side of it. And I think, if I remember right, some of you folks were with Central Christian Church here in Indianapolis, and 2019 into 2020, we did some equipment replacement. You guys did some window stuff. It was a great project that we were able to do with you guys, so I appreciate that. HVAC units, like was addressed early on, has to be sized for what you're doing. Oversizing a unit can be just as inefficient as undersizing a unit. So that's very important, and that's where our engineering skills really come into play in helping you decide, is this right for what we have now? Did we build on? Did we cut the building in half? Have we put up walls? That sort of things. Building controls were spoke of, and again, I can't emphasize that enough. Churches are notorious for only being around and used maybe 50% of the time, but I'd say 20% of the time. Most of the time during the week, they're empty or almost empty. There may be some offices in use, but the big uses is on the weekends or maybe the evenings. So that's where building controls and zoning your buildings comes in and is very important in energy conservation. Again, ventilation, we talked about bringing in good air. And that's very important nowadays, especially what we're all going through with the pandemic. The CDC and OSHA have made recommendations on building ventilation. What's the right thing to do? How much do you need? And we got to clean it. Do, air filtration, MERV rating on filters. I'm sure you've all heard that. I could talk a week on just ventilation. But then there's cleaning the air. There's UV lights, bipolar ionization, things like that can be added to units. That's all part of the building ventilation. We don't want sick building syndrome. Electrical connections, something people don't think about, but there's energy wasted, and the thermography cameras will show you this in your energy panels. You can have overheated panels, you can have loose connections. It may benefit you to ask your power company to bring in a larger service. And with that, maybe we can lower your energy bills. Just touching on these four subjects, we can experience up to a 30% decrease in or anticipation in savings on your energy use. we can go ahead and move to the next slide. Indoor air quality, we touched on that. Again, this could be a whole nother topic, but it is important, especially nowadays, that we're bringing in good air when we're bringing in air. Again, get that air barrier tight and then bring in good quality air. And it's very important, and it is energy savings. And we can talk more about that offline, or if you guys have questions about that, but there are so many different things nowadays. Technology is just crazy about getting this, and there's some really good products out there. There's also some scams. So you want to be careful of what you're getting when you're talking about indoor air quality. We can go to the next slide. Kim?
This slide just shows some examples of some customers that we have worked with over the past 20 years. It represents some churches, some municipalities, some private industries, some schools. Just gives you a cross section of the type of work that we've done for various customers in the Indiana area. You can go to the next slide.
Okay, let's talk payback. Okay, that's what everybody wants to know. All the treasurers of the churches, all the financial people. Okay, I'm going to spend $500,000. How am I going to get this paid back? Well, most of us are from Indiana, and we're blessed. We have fairly cheap energy compared to some of the places in the United States. But that doesn't mean that it's free energy. We can get free cooling if we have the right controls and economizers and things like that. But payback can be achieved if we bundle the solutions from air barriers, building envelopes, lighting, and then equipment upgrades. There is financing and leasing and grants available. I work with a leasing finance company that specializes in non-for-profit organizations, schools, churches, clubs, things like that, to help them. And that's their specialty. A lot of equipment manufacturers will also offer leasing. And along with that leasing, there's service available. There's PM programs, preventative maintenance programs that are available. So all worth looking into. I guess what I want to say is, when you ask for a HVAC upgrade or you're looking at building envelopes, the first thing we do when we get that quote is we go to the bottom line and we say, oh my goodness, holy cow, how am I ever going to pay for that? That can always be handled. And so I just want to let you guys know about that right up front. And a lot of the utilities that you see listed here are still offering rebates of some sort. Not as good as they used to, but there are still rebates available. I encourage you, if you're thinking about a project, reach out to them first, see what they are, so then the projects can be tailor-made, hopefully, to their rebates to utilize and get the most of that rebate dollars. And then I want to talk about the benefits of preventative maintenance, and it's on this page because preventative maintenance will save you money and will pay back. Let's talk about new equipment. You got new equipment in there, and the first thing you think of is, well, I ain't gonna have any problems with this equipment. Now it's brand new, but we have to maintain it. You change the oil in a brand new car. You change the filters in a brand new furnace. That helps you continue to get your payback. If you let it go, now you're gonna have repair bills, and that's going to erode your payback. Now, preventative maintenance on older equipment. If we do our preventative maintenance correctly, we are going to help maintain the life of that equipment. Sometimes you can get rebates to upgrade equipment, putting VFDs on equipment. You can get rebates to go through your boiler traps and redo all your boiler traps. There's all kinds of rebates out there on older equipment, but we have to maintain, it's even more important to maintain that older equipment at a high level, so that the money that we did spend, we're not just throwing it down the drain on additional repairs. Next slide. So
as we're wrapping up, I think you've seen a lot of great resources and entities that can help you identify problems and companies that can help you solve problems. We like to think that we have a really great, excellent service program with a personal touch. We do a lot of account management and regular communication with our customers, and we try to really build long-term relationships. We have many customers for 20 and 30 years, and I think that's, in this day and age, it can be a little bit more difficult. We do want to be that partner. We do want to be a resource for you. It seems like there's a lot of great information in this program. Everyone has some great ideas that you might have too many resources, but I think that we'd like to be one of them. And if you want to go to the next slide, it is just in closing, it has the contact information. Ted Shea also is the manager there at our Comfort Systems USA office, Indiana office. And this is just, we have our 24/7 emergency hotline on there for, just so you'll know about it, and our address in Indy. And thank you very much for your time. We enjoyed sharing this and learning more about you.
Thank you, Kim and Don. I certainly didn't know all that about your company, but it's good to hear.
Yeah.
I'm going to keep us moving. Our next speaker is Lance King. Lance is the Energy Services Operation Manager in the Midwest Zone for Siemens Industry Smart Infrastructure. He leads the energy engineering team for the Midwest branches. He's responsible for a team of professionals focused on providing customers with the design and implementation of energy operational solutions, including energy savings projects, retrofitting energy conservation, education, on-site generation, and energy supply management. Lance has been with Siemens since 2008 and held various positions within the energy industry. He has developed over $100 million worth of energy and infrastructure projects for commercial, industrial, hospital, and municipalities, K through 12, higher education, and public housing markets. He's also a registered professional engineer. Is Lance still with us?
Yep, I was able to, I got kicked off right at the worst time. Sorry.
Okay. Well, we are hearing you and we see your name, so go ahead.
Yes, thank you, Ray. Angie, if you can present my slides there, please.
You're on.
Awesome, thank you. So I just wanted to, I have a pretty short slide deck here. I wanted to try to have it, make sure to leave some time for questions. I know there was a lot of great presentations here. I just have a couple, and I know if you're not familiar what carbon neutral means, it's basically trying to go to zero energy use or all renewable energy. And so I thought I could present something that was a pretty practical approach to first steps to carbon neutral. So if you want to go to the next slide. So this is a great slide, a graphic that kind of shows how the best way, almost the process of, in my opinion, is the best way to approach. So all the presentations that were before me really focused on the reduce of the energy consumption. And that's exactly where I would suggest starting. I know that from carbon neutral, a lot of times what you see in the media is the wind turbines and solar panels and things of that nature. But I always suggest to everybody, the first good step is reducing your consumption, which then dictates how large of systems you really need as a solar panels, as an example. So if I lower my consumption, I lower my load, which therefore my solar panels, I need less of them. So this is a great slide that kind of dictates that. And so you would want to first reduce. And then the next thing is the procuring. So you want to make sure when you're buying it from the utility company, you're buying it at the best rate that you possibly can. And then lastly, you want to try to look at on-site renewable or on-site generation and producing your own. So the graphic around that is kind of showing that a lot of this discussion and these decisions are made through data-driven decisions. And that's where I'm going to kind of give you some practical steps of where you can focus and how you can focus on where to start for energy consumption. So if you want to go to the next slide, please. So here are some great statistics that I found, that of the existing systems, 30% of your energy in buildings is estimated to be used inefficiently or unnecessarily, much like how the previous presenters and others have presented from building leakage and using thermal energy. Really, it's kind of making your systems working more efficiently in what they are. The other part that I thought was pretty funny was when I was putting this presentation together, I found this quote that says, "In God we trust, but make sure all others must bring the data." So I thought that was pretty fitting for this presentation, that we need to make sure that the decisions that we're making aren't based on gut feel. They're really data-driven type decisions. And that's what that next statistic there is suggesting, that 15 to 30% you can get an estimated in energy reduction through applying some data-driven insights. So I have a little bit of personal experience from the standpoint of working side by side with facility directors within the church. My local church here, a buddy of mine is the facility director, and constantly sending me information on how his units are working and how we can best optimize those. And that's always the first place we start, is with the data and doing that. So we can go to the next slide, and then the next slide will kind of give some practical applications. Is what next? Where do we go from here? So how I know I want to make this data-driven decisions, but where do I start? So I think the easiest way to start is through, and it's free, is the Energy Star portfolio. So I have these set up from left to right as far as what I think is the best practical way. So if you're not familiar with Energy Star Portfolio Manager, it's a real quick and easy way to kind of benchmark your building, see where you're at, and see where you should be focusing your time. Is it on the natural gas side? Is it on the electrical side? Is it systems that you're using in July compared to systems that you're using in December? It's a really good, quick and easy tool to use. The underlying data it uses is what they call CBEX, which is the Commercial Building Energy Consumption Survey. And roughly every 4 to 5 years, they come out with, it's a national data set that they pull. And so it's updated every 4 or 5 years. It was originally created by the EPA. So the next slide here is so one that, I mean, I did a little bit of research here on, and I know Ray can speak to it probably for days, but from the best I can tell is the Energy Stewards online dashboard, where you can kind of track your energy usage and see year over year. You can compare one church or one congregation to another worship facility. So it looks like it's a pretty good dashboard from that standpoint. And the last one, I will flat out say, is probably not the best approach for if you're a small congregation, but for a larger congregation, it may make a really good sense, which is the Siemens Navigator system, which is a data analytics platform. And you can pull in metering data. You can pull all of these different kind of points if you have a building automation system, that you can pull in the data and actually do machine learning type stuff for fault detection and fault detection and diagnostics. So you can really tune and troubleshoot where the problems are. One that I did not put on here, which I just flat overlooked, and I know Ray kind of prepped me that it sounds like a lot of the audience here may have some simple systems like furnaces and things like that, which you utilize more of a residential type of equipment. I'm a data geek, and so I have quite a few of connected, we'll call them connected devices in my home that I kind of use all that data. So I have a smart thermostat. And so sometimes you can use something as simple as a smart thermostat that will drive a lot of this data-driven analytics that will show you energy usage across the month predicted based on how often that furnace is running and what temperature you have it set at. When you leave that area, it'll automatically go into an unoccupied mode based on occupancy. So there's a lot of other residential type stuff that if you're a smaller congregation where you have furnaces and things of that nature, those would be a really good fit. So that's kind of, I know it's a short presentation here, but I wanted to try to leave as much for questions as possible. And I also knew that I could probably run the risk of geeking out on some stuff. And so I wanted to leave myself some time for that. So here's my contact information. Reach out to me anytime. Honestly, I'm more than willing to help. I'm more than, if it's not a good fit for what the company, what Siemens can offer. Me personally, I love doing this stuff. And so I am more than happy to help and get you to the right person if it's not me.
Thank you.
And that's all I have.
Thank you very much, Lance. We appreciate it. I can get sort of geeky along that line too, and sort of salivate when I start hearing about all these things that telling you how your equipment's working, and so that you don't wake up in the morning and say, is the sump pump really working? You know, so that's a big deal. I'm going to go back to gallery view at this point, and I'm going to say to anyone who would like to ask a question, you unmute yourself and just give it a try. I'll try to be a traffic cop here if anybody wants to, go ahead. And while you're getting up your courage, I have a couple questions. Yeah, there are a lot of questions, but one of the ones that might be, I don't know, perhaps best directed to Don and Kim is, how do you manage heat pumps? My perception is we have to stop burning gas, even though it's the least expensive as far as our heat sources. But if we're going to get the carbon neutral, we got to stop burning things. And so my congregation, as an example, put a big heat pump on top of our sanctuary. And we've had some significant problems with it from time to time. So I'm finding that some technicians are not that great at solving problems with big heat pumps. And more to another point is, how do you manage heat pumps? I have a heat pump in my house, and so I know that if my temperature goes down in the middle of the night, I'm losing less heat through the walls, but then the heat pump comes on, and instead of just using the heat pump, it wants to get it back up to temperature fast, so it turns on the resistance heat. Do you give any insights about that you've run across?
Sure. Kim, you want to take that? No. No, I'll tell you one thing, keep in mind, heat pumps are just so much better than they were in the 70s and the 80s. I've been doing this for over 40 years. And in Indiana, back in the 70s, I'd have told you, don't even waste your money on heat pumps. Remember this, you get heat out of air until it is a minus 460 degrees Fahrenheit. There is always some heat in there. Now, how do they do that when it's 50 degrees outside or 40 degrees outside? That's a mechanical thing where they use inverters in the compressor and overspeed and all that. How do you manage it is the controls, okay, and maintenance. And I'm gonna tell you, those two things go hand in hand. And you put a heat pump system on there and you're relying on an old conventional, God forbid, mercury thermostat, or maybe just a programmable thermostat, make sure that it is a heat pump stat. Okay, that's very important, so that you're running the heat pump when you should be and running the auxiliary heat, whether it's gas or electric, and hopefully it's electric. That's very important. And the controls, let's say if it's your church or congregation, even your house, if it's a large house, zone it. Okay, so that's going to allow your heat pump to get the hot air where it's needed most. And perhaps in an unoccupied space, the heat pump doesn't need to maintain 72 degrees or even 68 degrees. It can be down to 50 or 55 degrees. Let that heat pump do its job. Maintenance is the key, okay? Filters are critical on a heat pump because you have to have that good heat transfer across the coil. You've got to get the air, the right proper CFM across that coil. Outside, what do you see outside? A lot of people say, well, my heat pump, I go outside in the wintertime and it's just a ball of ice. That's an issue. It should defrost, just like your refrigerator defrosts. In the summertime, it's an air conditioner. Cold air comes out into your house, hot air goes outside. In the wintertime, that thing reverses, and it actually has a valve in there that reverses the refrigerant flow so that now the hot air goes into the house and the cold air goes outside. Well, what happens, just like we talked about with the air barriers, hot air, cold air, condensation, it can freeze. That's what happens on the outside of your unit. If that freezes too much, then we get into an airflow issue across the coil and we lose the efficiency. All of a sudden now the heat pump can't work properly, your electric heat's coming on and your bills are going up again and you're losing the energy efficiency that you hope to gain from the heat pumps.
Thank you. Anybody have a question now? Okay, go ahead, Andrew. Yeah, you have to unmute.
Okay, now I got it. Very complicated. I'm looking at a school building attached with the church here. It's 26 classrooms. It's a K-8 building. And the air exchange units in the classrooms they're about 60 years old in all the rooms. So I'm sure the exchange rate is a lot more than what it is today, what's required. What kind of rate are we looking at? We're probably looking at something like 30 to 40% currently fresh air intake of what we're getting, but what is what they recommend for like today, and is that easy to justify?
So yeah, just to complicate that question a little bit more, I know in my congregation, I'm always screwing things down to have less air coming through those units. But with the COVID situation, we're all getting anxious to get back to having in-place church. You're obviously having a school. What is the deal? Don, that may be your question for you. It might be for Monroe as well.
Well, I'll jump on real quick from what I know, and I'm no engineer, but I will tell you that ASHRAE is recommending 15 CFM per person. Okay, so keep that in mind. If you're putting a lot of people in these rooms, you want 15 CFM per person. Okay, so that's kind of, it helps you know how much air you've got to bring in and how much air change over. That's difficult in churches because one day this room may hold 150 people. The next day it may be a choir room and it's got 15 or 20 people in it. How do you manage that? Again, I'm going to go right back to controls. And I think that's where some of our other experts on here from Siemens and our engineers with the building envelope and the air, they can help that. But keep in mind, I think right now the key word that we're emphasizing is 15 CFM per person. I'll mute and someone else can jump in.
Okay, great.
Yep. So I can answer a little bit more onto that as well. What ASHRAE is also recommending is, I want to say it's 40 to 60% relative humidity. Now, understandably, if you don't have a humidity sensor, then you can't control to that, obviously. But they kind of base it more so on 40 to 60% relative humidity, and I want to say like right around 60 to 65 to 72 degrees is where they see the actual transmission of COVID falling down, because the droplets, the more moisture that's in the air, the less it transmits in essence. Now, I'm not a medical professional. I just know the science from a transmission standpoint, and that's what ASHRAE is recommending. The other thing I was going to say is from a control standpoint is, or from a design standpoint is, that 15 I think you said 15 CFM, correct, Don, per person? That 15 CFM, I would caution somewhat against it because it's dependent on the design as well. If your
Agreed.
coils can't take that, let's say like if you have 150, you may never reach set point. And so then you have uncomfortable people. So I would caution never go past the design. It
Right.
is the other. So
Agreed. That's why you really need, and I can't emphasize this enough. I run into it all the time, especially when someone's going, we see a group do a remodel. The first person they reach out to is an architect. And if there's architects out there, no, I don't mean any disrespect, but then they want the HVAC company or the mechanical company to do the engineering. And really, your architect and a good mechanical engineer need to work hand in hand in order to get you the right building. And they want to cut corners, and they always want to leave out that mechanical engineer. And because, well, the HVAC company can do that. They can tell me what size equipment we can use. We're good at what we do, but we're fortunate at Comfort Systems to have those engineers on staff. Yes, but some of the smaller companies, local companies may not have that, and they may only design or give you something based on the load, what the load of the building is, not necessarily what you're using, maybe what the equipment is. Like Lance was saying, you've got to be careful. Just because ASHRAE says this, you might not be able to get there. So how do you get close to it? Lance, you brought up some great stuff. I appreciate you getting on board with that. That was great. Thank you.
Thank you. Anybody else have any questions?
Hi, Ray.
Yeah.
Yeah, thanks for the great presentations, everybody. My two questions. First one is for a congregation that's thinking about changing out their HVAC or making updates, but they also may be considering solar down the road. What's the recommendation on the approach?
If I could take that real quick, if you're considering solar and putting it on your roof, the first thing you want to do is get your roof in shape. And that may mean, again, the building envelope, that may mean extra insulation. Maybe it's just a new roof, okay? Then HVAC doesn't care where it gets its power from. So then you just look at how the best, most efficient HVAC. But I can't emphasize enough, make sure your roof is the best that it can be. Do not cut corners if you're going to put it on your roof. Now, if you're going to put it in a 2-acre lot on the south side of the building, terrific. That's fantastic. But if it's going on your roof, make sure, number one, it's structurally sound and it can support it. You got to match it with your snow load and make sure that you're up to snuff. And if anybody else wants to jump in, the engineers, go right ahead.
Thank you. Second question kind of follows up with the air. I was just wondering, can you translate that into air changes per hour? And if so, does that mean for COVID, but also comfort and health? How does that impact energy efficiency? Is it more air changes than energy efficiency goes down?
Yes.
I'm going to let one of of our other engineers handle it. They've got the knowledge more on that than I am. I'm going to mute my mic.
Well, I was hoping.
So the simple answer is yes.
Yes.
Yeah, the simple answer is yes. The more outside air you bring in, or the higher the air changes per hour, the more unconditioned air you're bringing in, which means you're either heating it and cooling it. The only exception to that is if you're in the shoulder months where you're basically free cooling, or we're almost like here in Michigan, like what I did today, where my wife left the door open and we shut the thermostat off. That would be the only time where you're getting the air changes more, but you're really not impacting the energy efficiency. I think that answers the question.
Yeah, thank you. And I'm just wondering, is there a standard? I think I'm reading these days like 5 to 6 changes per hour. Does that sound about right, or too high, too low?
Monroe, can you help us out on that?
Ray, I would say that I don't have the engineering stats to give an actual recommendation on those rates, but just to point out that this whole air exchange business is very tricky because we need minimum amounts of ventilation in buildings. And by its very nature, that means we're bringing outside air in, which means we're adding the load to either our heating or cooling processes. So while I can't give you the number, and I don't think it would be appropriate to do that, not really knowing, even for an engineer, not knowing exactly your situation, these are very, very important questions. So I applaud you for having them and wanting to go through them. And it does require an engineer to get it right, because these ventilation systems, especially on public buildings, one of the things I do as a non-engineer is I go through and I blow the whistle on folks, especially in a church, who have maximum ventilation going into a building 24 hours a day when they're using their building only sparingly or only on weekends. So there are these issues. And in our work with building envelopes, we blow the whistle on that, but we don't turn around and do the engineer's job of trying to put the exact number on each individual building. This is a process that needs an answer for your individual building and how it is performing at the time.
Thank you, Monroe.
Appreciate
Yeah,
it.
thank you.
Yeah, this is Colby. I just want to add to that real quick that I want to echo on this point that I'll go into a church and they'll have the outside air dampers open at 100% all the time, just for a number of reasons. And I understand with COVID, we need to be careful. You know, ASHRAE recommends a 2-hour flush before and after service, you know, since COVID, but be very careful because especially for like in Houston, especially in the summers, and I know our weathers don't really match, but maybe more in Southern, you have this humid air coming into the building. You have to dehumidify it in the summer months to 32 degrees to wring the moisture out, right? And then you have to reheat it many times with electric strip heat. So it's very, very expensive. But I agree, you have to get it right, but you don't have to have it open 100% of the time with the HVAC running 24 hours a day. That's extremely expensive.
Thank you, speakers. Yeah, Daryl, go ahead.
HVAC question. Many split ductless heat pumps are much more efficient now. They can effectively heat down to close to 0, maybe below 0 Fahrenheit. My question is, can a mini split ductless heat pump be effective for a large indoor space when it's near 0 outside?
I can answer that real quickly. Not without auxiliary heat. They cannot do it alone. You will need some sort of auxiliary heat when it gets down to that. Most manufacturers, Mitsubishi, Carrier, Samsung, they're recommending 10 degrees. And they'll sell you on, oh yeah, we're good down to this. But in all reality, mini splits are great and they have their purpose. We install them all the time, especially the new VRF systems, the city multiples. They are great. And they are older buildings, when you can't get ductwork in, they're fantastic. But just remember, you will always have to have some, in colder climates, always have to have some form of auxiliary heat. And possibly, depending on the room size, I encourage people, fans. The proper type of fans, again, get the fan cycle. That doesn't mean going to Lowe's or Menards or Home Depot and getting a Hunter fan and so we're going to put 6 of these Hunter fans in here and that's going to get the heat down where we need it. No, fans is a critical part of the ventilation, and having the right type of fan for your facility to do what you want it to do is also critical, or that fan's just up there eating energy up and not doing what you want it to do. So mini splits, great. I love them, love to install them, but they're not a standalone piece of your HVAC equipment. Hope that helps.
Thank you very much. Thank you, speakers. Obviously, we've we've just got to the tip of the iceberg in what we're really talking about here and what's possible and what we're facing. This has been really good. I'm hoping we can do more of this. Let us know how you feel about it. I've learned some things, and I know there's a lot more to learn. I did have one more quick question. Don, what is it, MERV? Is that the word to describe the filter density or whatever it is?
That's right, MERV, and I should know what that stands for. I don't. I'm sure one of our other panelists do. But before COVID, just about everybody was using MERV 8. Then they went to MERV 11. And then OSHA said, hey, the best thing to do is MERV 13. You get above MERV 13, which there are other MERVs, and you get up close to the HEPA range. I want, if I could emphasize this really quick, don't rush putting in a higher MERV filter until you consult with your HVAC person or call me, because it can have an adverse effect on the airflow going across your coil, and it can cause your coil to ice up. Or what I've had places put in MERV 11 filters, and then they end up changing the filters every month because they are that efficient. So you've got to balance that, and that's why I say just don't rush out and buy a higher MERV filter and think you're doing a great job. There's more to it than just that.
Great, thank you. I'm glad I threw that in there at the last minute. Okay, we need to wrap up. Thank you again, speakers, and thank you all for attending. I hope you've gotten your money's worth out of this. I want to encourage you to give serious consideration to joining up with to get our 100 Thriving Faith Community congregations going. I can just another little tidbit here. I know one congregation that has saved over 50%. They reduced their energy consumption over a base year by 50% more than 50%. And I know another congregation that spends 13 cents per year per square foot of their buildings. That's the lowest I've run across at this point. So those are sort of some benchmarks that you can sort of say, okay, could I be that good? And then just finally, we can't waste time on this, folks. The earth is warming rapidly. And if you see what we can do this. I think within the next year or two, we're going to have some congregations in Indiana that have reached net zero as far as carbon emissions. I think if we work together, share stories, share experiences, more of us can get there. So thank you very much. Keep in touch. We'll send something out to you tomorrow, and I appreciate very much having you here. Adios.
Thank you.
You're very welcome. Good.
Thanks, Ray. Thanks, Angie.
Thank you. Appreciate it. Appreciate y'all.
Okay, Angie, I guess our work is cut out to get something out there tomorrow. So you should let me know what you need from me. I think you wanted maybe some telephone numbers or something.
I think I have everybody's info except for Monroe's phone number.
Okay. Okay. I'll see what I can do about getting you that.
Okay. I'll send that and link to Energy Stewards, link to.
Yes. Yeah, I'll send you the latest version of Energy Stewards, Thriving Faith Communities, and the frequently asked questions. I think we should also throw in there